Okay, question C. Heptane belongs to a homologous series of compounds called alkanes. The general formula for alkanes is CnH2n plus 2. Heptene belongs to a homologous series of compounds called alkenes. Give the general formula for the alkenes. Okay, so the one that I'm guessing that most of you have written is CnH2n. Although the truth is, actually, you could have used any letter other than N, so something like CXH2X would have been acceptable, or any letter that you feel like CP. H2P would also have been fine, as long as it was consistent throughout the entire compound. But the one I think you probably would have gone for is CnH2n. It is important, though, that you didn't write Cn plus H2n. Okay, this implies that they are two different compounds, or two different molecules, rather than one compound like it is here. So this one is wrong. It had to be CnH2n. II says, complete the following diagram to show the structural formula of heptene by inserting lines to represent the covalent bonds between the carbon atoms. Okay, right, now I think an important bit here then is the question says by inserting lines, not adding in any other atoms. So if you were to look at this sort of structure down here, it already has 7 carbon atoms, and it already has 14 hydrogen atoms, which is our molecular formula. So we couldn't add, for example, oh, wrong pen, sorry. We couldn't add like more hydrogen atoms. Okay, that is not what the question wanted. You can only insert lines. Now, what's important here to remember is the number of bonds that each atom can make. So hydrogen can only make 1 bond, and carbon will make 4. Okay, so we need to sort of make sure that they've all got the right number of bonds. Now, the first thing I do is, this is one compound, so these things have to be bonded together. It has to be one thing bonded together. So I would make them all so that they bond together. Add a backbone into the back. Okay, and then I would add up to make sure, to see, sorry, the number of each bond that they've got. So I'm actually going to start at this side, be unconventional, and I can see that this carbon atom here is has 4 bonds, which is what we want, and each of these 3 hydrogen atoms has 1 bond, and we also want that. This carbon atom here now has 4 bonds, and these hydrogen atoms have 1. The same with this one, and this one, and this one. Okay, so all of these atoms on this side have the correct number of bonds. This carbon atom here has 1, 2, 3 bonds, and it needs to have 4. Okay, it needs to have 4. Now, as we've said already, we can't add in any more hydrogen atoms, so I couldn't add a hydrogen atom in down here because we've used all of the ones that we have. So that means there needs to be a double bond here somewhere. Now, if I was to put a double bond in this side, which means that this carbon atom here now has 4 bonds. This one now has 5 bonds. It's got 1, 2, 3, 4, 5. That's too many bonds for carbon. It can only have 4. So that double bond cannot go there. Just a single bond. The double bond goes at the other side. And what that means now is, so this has now got 1, 2, 3, 4 bonds, good, and this hydrogen's got 1. And if we look at this side, these hydrogens both have 1 bond each, and this carbon has 1, 2, 3, 4 bonds. Okay, so each carbon atom's got 4 bonds, each hydrogen atom's got 1. Now for this question, what you got marks for is the double bond in the right place, and then all of the other carbon-carbon bonds being single carbon-carbon bonds. So that's where the 2 different marks come from. Okay, D. When heptene is added to bromine water and the mixture is shaken, a reaction occurs. State the type of reaction and give the colour of the bromine water before and after the reaction with heptene. So it'll be 1 mark for each of these. So the type of reaction is an addition reaction. The mock scheme allowed additional, but that's a bit weird. Normally we just say it's an addition reaction. So you've got an alkene here, and you're going to add in the bromine water across that double bond. The colour before then, strictly speaking, what we wanted was orange. Okay, and that is the colour that I'd like you to go away and learn. Technically speaking, they also allowed yellow or brown, but anything that mentioned red was wrong. So if you said reddy orange or reddy yellow or reddy brown, you were wrong because you said the word red. Okay, it had to be really real orange there. And the colour after then is going to be colourless. Now, lots of you will have written things like clear or transparent or looks like water. The mark scheme says ignore those. It doesn't say reject. It doesn't mean that they're wrong, but you had to say colourless. So if you said clear and colourless, that would be fine. You get the mark. But if you've just said clear, you wouldn't get the mark. So just be careful with that one. It should be colourless. E then, explain in terms of the bonds present why heptane is described as saturated and heptene is unsaturated. So 2 marks here then. So heptane is saturated. I would say as it contains no carbon-carbon double bonds. You obviously could say the direct opposite of this. You could say that it only contains carbon-carbon single bonds. That is also absolutely fine. They're the same point, just opposites. And then for the second mark, heptene is unsaturated. As it contains a carbon-carbon double bond. Easy peasy.